startling announcements by using leading astrophysicists Neil deGrasse Tyson and Michio Kaku have brought Pluto again into the spotlight with a surprising revelation. They propose that this icy globule is on a capacity collision path with Neptune. However, how should this happen, and what would be the effects of this sort of huge event? Are we witnessing an extraordinary astronomical phenomenon? Or is there something more to this forthcoming cosmic collision? Be part of us as we discover the opportunities of a Pluto-Neptune effect. Pluto, a former planet that turned into demoted to a dwarf planet in part due to its abnormal orbit, stays a subject of fascination and look at in the astronomical network. Consistent with recent predictions through leading scientists, Pluto's trajectory is dangerously near Neptune's. Tyson and Kaku are elevating the red flag of a possible risky collision among those two celestial bodies, which may be a massive hazard to Earth. How is such an event even viable? Pluto's journey around the Sun is unlike every other planet in our solar gadget. It takes a mind-blowing 248 years to complete a single orbit. On account that its discovery in 1930, it hasn't even finished one full revolution. The intrigue does not prevent there. Pluto's direction is marked with the aid of its pretty elliptical form, deviating considerably from the near-circular orbits of the essential planets. What makes Pluto's orbit even greater odd is its inclination, angled at 17 degrees to the ecliptic aircraft. The route Pluto strains is a great deal steeper in comparison to the alternative planets, including layers of complexity to its orbital sample. One of the maximum fascinating elements of Pluto's orbit is its intersection with Neptune's direction. For about 2 decades in every orbit, Pluto absolutely comes in the direction of the solar than Neptune, defying what we might assume from their positions within the solar machine. This leads to the herbal question: why hasn't Pluto collided with Neptune? The answer lies inside the gravitational affects of other planets. The study of Pluto's orbit started out quickly after its discovery. Initially, astronomers struggled to understand its specific trajectory. In contrast to the alternative planets, whose orbits lie surprisingly close to the ecliptic aircraft, Pluto's route stood out with its steep inclination and elliptical shape. The thriller deepened with the realization that Pluto's orbit definitely crosses Neptune's. The steadiness of Pluto's orbit amidst these complexities is evidence of the intricacy of space mechanics. The three-body problem in space is set identifying how three are bodies like Pluto, Neptune, and the Sun move and affect each other with their gravity. It is like seeking to expect where they will move based totally on in which they start and how they pull on each different. In Pluto's case, this hassle shows how its direction, Neptune's path, and the solar's gravity all work together in a complex way. The phrases axial vibration and latitude libration, at the side of the VSK oscillation, are part of this puzzle. According to astrophysicists, what is keeping all planets of their orbits is axial vibration. In the context of Pluto and Neptune, this time period method that whenever Pluto crosses Neptune's orbit, it is positioned at the least 90 degrees away from Neptune. This spatial separation is essential in stopping their paths from colliding. Range libration, on the other hand, refers back to the vertical movement of a celestial frame in its orbit. For Pluto, which means that when it comes closest to Neptune or any other massive planet, it is located appreciably above their orbital plane, imparting an additional layer of safety from ability collisions. Any other important component in this equation is the VSK oscillation, named after 3 scientists, von Zeipel, Loff, and Kazai, who studied how things move in space. This oscillation describes how 3 space gadgets like Pluto, Neptune, and the Sun pull on each other with their gravity, affecting their movements. In Pluto's case, VSK facilitates us recognize why its direction around the Sun is so uncommon. Despite the fact that Pluto's course appears erratic, this oscillation enables maintain it moving easily over lengthy durations. All of these components help preserve Pluto's orbit solid, making sure it doesn't crash into Neptune or get thrown off direction. The three-body trouble assists in information how those paths alternate due to the gravitational interactions of area objects. Analyzing this allows us find out about Pluto, our solar device, and distant worlds. Numerical simulations inside the late 1980s revealed that regardless of these solid houses, Pluto's orbit is technically chaotic. Minor deviations in preliminary conditions can result in full-size differences over hundreds of thousands of years. But The precise properties of Pluto's orbit have been located to keep balance over distinctly long timescales, successfully maintaining chaos at bay. Latest laptop tests have helped us recognize how the large planets like Neptune, Jupiter, and Saturn affect Pluto's route around the solar. Neptune has a unique connection with Pluto, wherein for each 2 rounds Pluto makes around the Sun, Neptune makes 3. This connection facilitates hold Pluto's path steady. However, Neptune isn't always the only one assisting. Jupiter's gravity also plays a massive component in preserving Pluto's orbit secure and stable, with Saturn contributing as well. These tests display that Jupiter's gravity alone is robust enough to make sure Pluto remains on a solid course for a very long time, doubtlessly even billions of years. It is as though Neptune, Jupiter, and Saturn are all working together to make certain Pluto maintains moving adequately in area without going for walks into problem. Those phenomena are important inside the context of the universe for keeping the order and predictability of celestial bodies' moves. Without those mechanisms, the Sun device as we are aware of it would be an area of a whole lot greater chaos and unpredictability. Bodies like Pluto ought to probably collide with others or be ejected from their stable paths, leading to a domino effect on different celestial bodies. For Pluto, specifically with talks approximately it possibly crashing into Neptune inside the destiny, expertise its orbit is vital, supplying a clearer photograph of the Sun gadget's dynamic nature. The case of Pluto demonstrates how even the maximum apparently unstable orbits can gain a nation of equilibrium through the complex interaction of gravitational forces and orbital mechanics. It additionally highlights the importance of non-stop commentary and observe of those phenomena to better grasp our area inside the universe. Exploring the depths of space regularly leads us to confront the unpredictable nature of celestial bodies, and Pluto's orbit is a top instance of this unpredictability. The idea of orbital chaos, which refers to the sensitive dependence of a celestial body's path on its preliminary situations, is vividly illustrated within the case of Pluto, which means that even mild versions inside the dwarf planet's function or velocity can considerably exchange its long time period orbit. The usage of PC simulations has been immensely useful for scientists in figuring out how Pluto moves in space. Those simulations employ complicated mathematics to imitate how Pluto and different space gadgets like Neptune pull on each different. By way of changing small info inside the simulations, astronomers can see how even minor changes can result in full-size differences in Pluto's trajectory. Lower back inside the late 1980s, these simulations discovered something interesting about Pluto's course. Even with factors like axial and range libration maintaining it constant, its orbit can nevertheless be pretty wild and unpredictable. If you begin with just a tiny distinction in Pluto's initial function or velocity, its course can grow to be looking definitely specific over many years. Yet, even amid this chaos, Pluto's orbit remains strong for an exceptionally long term, suggesting that its adventure around the Sun has a shape of order to it notwithstanding appearing chaotic before everything glance. Predicting cosmic activities, mainly those involving chaotic orbits like Pluto's, poses good-sized, demanding situations. The inherent unpredictability of these systems manner that long-time period forecasts are regularly fraught with uncertainty. Whilst numerical simulations offer effective tools to apprehend and count on the destiny paths of celestial bodies, in addition they spotlight the limitations of our predictive abilities. Those fashions rely closely at the accuracy of initial conditions and the complexity of the interactions they simulate. Any moderate error or oversimplification can result in massively distinctive results, making specific predictions daunting. Moreover, the chaotic nature of celestial orbits like Pluto's reminds us of the ever-evolving and dynamic universe. Even as we have made giant strides in information space, Pluto's case illustrates how an awful lot about the universe nevertheless stays unknown. Know how the gravitational influences of the massive planets on Pluto's orbit offers treasured insights into the wider dynamics of the Sun system. It demonstrates how the presence and function of every planet could have a ways-attaining results, influencing the stableness and trajectory of other bodies inside the system. So why are essential astrophysicists simplest now elevating issues about a possible collision among Pluto and Neptune, no matter all of the complex forces attempting to prevent such an event? Tyson presents a unique perspective at the mysteries of our solar gadget, especially the exciting case of Pluto. Recognized for popularizing astronomy, Tyson views the reclassification of Pluto not as a demotion, however, as a vital version to our developing understanding of the various bodies orbiting our Sun. His technique to celestial mechanics is certainly one of continuous getting to know and model. Tyson sees the complexities of orbits like Pluto's as a reminder of ways tons there's still to find out in space. The intrigue of those unknowns, consistent with Tyson, is what makes astronomy so charming. He keenly understands how space activities and discoveries shape public interest in astronomy, believing that occasions like Pluto's reclassification or its orbital peculiarities can have interaction the public's creativeness and curiosity about the universe. Tyson, together with other scientists, warns the public approximately the capacity threat of Pluto's randomized course. After years of reading Pluto, he has raised concerns that the three-frame hassle may definitely pose an enormous threat with regards to a collision with Neptune, which he shows is long overdue. He emphasizes that such a collision should absolutely adjust the universe's balance and cause catastrophic effects, reaching all of the manner to Earth. If Pluto and Neptune were to collide, it might be an unprecedented and catastrophic event in our solar gadget. The collision might release a tremendous quantity of strength, probably shattering Pluto, given its smaller length and icy composition. Particles from the collision could unfold across the solar device, probably creating hazards for other planets and their moons. For Earth, the results of such an event would be devastating. At the same time as Earth itself might not be immediately impacted by using the collision, the ensuing shockwaves or gravitational shifts may want to have lasting results on our personal planet. Tyson's alarm should be taken seriously, as one of these collisions ought to create ripples that extend past the instantaneous region of the two colliding our bodies. As of now, there is no instant hazard of a Pluto-Neptune collision. However, the prospect of such a cosmic occasion serves as a reminder of the unpredictability and chaotic nature of the universe. With Pluto's orbit last stable for now, our understanding of space maintains to conform. To have a look at of Pluto and Neptune's interactions, particularly through computer simulations and gravitational models, offers us a fascinating glimpse into the dynamic forces shaping the cosmos. The opportunity of a collision, though nevertheless a far-off event, encourages us to, in addition, discover the mysteries of the universe and deepen our understanding of the forces that govern it.